In this lesson, we'll talk about how to solve a quadratic by completing the square. Before we do that, I would like to talk to you and remind you about something called a perfect square trinomial. So if you'll recall, a perfect square trinomial would be something that, say, we could write like this: x minus 3 quantity squared. And we know that that meant that we had x minus 3 two times. And the pattern that we looked for in the perfect square trinomial was that the first term was the first term squared, and the last term was always added, and it was the last term squared, and the middle term was twice the product of the two. So x times minus 3 is minus 3x, and doubled it, we'd get minus 6x. So this trinomial would factor into x minus 3 quantity squared. So we're going to use that in the next page to come up with what this value should be in order to make it a perfect square trinomial. So just remember that to find this value, it was twice the product of the two. Twice the product of the two. So when we are completing the square, what we're going to do, and first we're just going to practice by finding the c, and then we'll actually complete the square and solve an equation this way. But to find the c, we're going to take that b value and divide it in half, and then square it, because that's the pattern that we had found before. So we're going to take this middle value, which is negative 14, we're going to divide that by 2, and then we're going to square it. So negative 14 divided by 2 is negative 7, and negative 7 squared is 49. Now we should always end up with a positive number because we're always going to add c. So the c value should be 49. So x squared minus 14x plus 49 is a perfect square. To factor that into two perfect square trinomials, to two binomials, it would be x and then whatever this value is, minus 7 quantity squared. So again, if I FOILed that back out, I would get x squared minus 7x minus 7x and then plus 49. Same thing here, I'm going to take 8 and divide it by 2. And I'm going to square that, so I'm going to take 4 squared, which is 16. So my perfect square trinomial is x squared plus 8x plus 16. That would factor into x, in this case it's positive, so x plus 4 quantity squared. Now again, pay attention to this sign, because that's going to tell you whether it's a plus or a minus inside the binomial. So now that we understand how to find c, we're going to follow these steps in order to actually complete the square to solve a quadratic equation. So what we do is typically our first step is going to make sure that our coefficient in front of our x squared value is 1. And then we're going to isolate the two terms that have variables on one side of the equation. So what I'm going to do is I'm going to write x squared minus 6x, and I usually leave a plus blank because I know I'm going to add something there. I'm going to subtract this 13 to the other side, so now I have negative 13. Now, in order for me to add something to the left side of an equation, I have to add the same thing to the right side of the equation. So I'm adding the same blank. Well, how do I know what to put in the blank? That's what we just did. So we're going to take that negative 6 and divide it in half and square it, which gives me negative 3 squared, which gives me 9. So I'm going to add 9 to each side. This side will then factor into a perfect square. Remember, we're looking for that negative 3. So x minus 3 quantity squared. And on this side, negative 13 plus 9 is negative 4. Well, now I know how to solve this because I've done this before. I had the square root property where I'm going to take the square root of each side. The square root of the left is x minus 3, and the square root of the right is plus or minus 2i. I because of the negative inside the radical. To isolate the x, I'm going to add 3 to each side. So I get x equals 3 plus or minus 2i. If I needed to write each item separately, it's 3 plus 2i and 3 minus 2i. Oops. Set bracket, of course. Let's try another. In this one, I do have an a value that is greater than 1, so the easiest thing to do is to just take everything divided by 2 if it works out nicely and I don't have to deal with fractions. That gives me x squared plus 10x minus 5 equals 0. So that's step 1, divide both sides to make a coefficient of 1. Now I'm going to move this 5 to the opposite side, and that leaves me with x squared plus 10x plus blank equals 5 plus blank. Remember, I leave that blank there. Then I take that b value, which is 10x, so I'm just going to use the 10. So 10 divided by 2 squared, which would be 5 squared, or 25. So 25 goes in both of those spaces. And this side will then factor into x plus 5, quantity squared, and the right side I have 5 plus 25, which is 30. Now I'll take the square root of each side, which gives me x plus 5 on the left, and the right side, not super pretty. You look for any perfect squares that would come out. 4 doesn't come out, 9 doesn't come out, 16 doesn't come out, 25 doesn't come out. Nothing I can do. So it's just plus or minus radical 30. And then of course I would subtract 5 from each side to get negative 5 plus or minus radical 30. Here's another for you to try on your own. So press pause, do this question, then press play to see how you did. So for this one, again, I'm always going to get rid of that c value. Some people don't do it that way, and that's fine. Some people leave it on the left side. I think it's easier just to do it this way. I'm going to leave my x squared minus 4x plus blank equals negative 16 plus blank. I'm going to take my negative 4 and take half of that and square it. Half of negative 4 is negative 2. If I square that, I get positive 4. So I'm going to add 4 to each side. Then on the left side, I'm going to factor. That would leave me with x minus 2, quantity squared. On the right side, negative 16 plus 4 is negative 12. And now I'm going to take the square root of each side, which leaves me with x minus 2 equals plus or minus. Breaking this one down, remember it would be square root of negative 1, square root of 4, square root of 3. So that gives me a 2, and that gives me an I, and I still have a 3 inside. So plus or minus 2i radical 3. And then, of course, add the 2 because we're isolating the x. X equals 2 plus or minus 2i radical 3.